Lesson 3.1, Analyze Percents of Numbers. In this lesson, we'll learn how to understand, find, and analyze percents of numbers. The essential question in this lesson is, how do percents show the relationship between quantities? So we're going to take a look at 3 examples, and each of the examples is going to ask us to solve for a different piece of the percent puzzle. Take a look first at example 1. Find percents of numbers. Diego starts a 12-hour road trip with his phone's battery charged at 75%. Given his normal usage, will his phone last the whole trip? Explain. So take a look over at the picture. 100% battery charge means that he has 15 hours of usage on his phone. If his battery is at 75%, our job is to determine how many hours he can use that phone to see if it will last for his entire trip. One step that we can begin with is to draw a bar diagram. The bar diagram represents the hours remaining and the battery charge. So you can see by looking at the top bar here that this is a full battery. It is charged to 100%, and that means 15 hours of use. But what we know about Diego's phone is that it's only charged to 75%. Okay, so this is the part of the battery that is charged, and we're trying to determine how many hours he can use the phone at 75% charge. So we're going to create ratios to represent this situation. 75% out of 100, those are our percentages, is equal to the hours. And you'll notice that the ratio of hours is given to us in the same format. So for example, when the battery is charged at 75%, that is equal to X hours of use. That's what we're trying to find. But when the battery is charged 100%, then the hours of use is 15. So you'll notice that these connect because they're on the same side of that fraction bar. Then looking over in step 2, we're going to actually solve. Okay, so in our ratios here, look again at your proportion that we just created, those equivalent ratios. The parts are on the top, and the full battery charge, or the whole, is on the bottom. Okay, what it takes to charge the battery all the way up and how many hours that lasts. So let's go on to step 2 here. In step 2, we're going to use those equivalent ratios to solve for X. So think back to 6th grade and when you solved equations that had division in them. And this certainly is a division equation right here. This means X divided by 15. So how do we solve a division equation? Well, we turn it around into its fact family and we multiply. So you'll notice in the second part down here that we have done that multiplication step to turn it around. So we're going to multiply both sides of that equation by 15, and you get X that remains on the right side of that equation. And then we need to do this operation on the left. Now in order to do that, we're going to take it over here on the side, and I want to remind you how we multiply that whole number times the fraction 75 hundredths. And the way we do that is we do 75 times 15, and then we do 100 times 1. So on your calculator, do that 75 times 15 right now. And you should have gotten 1,125. Now you're going to simplify this fraction by doing that division, and we'll turn it into a decimal. So 1,125 divided by 100 is equal to 11 and 25 hundredths hours of battery life. So the remaining battery life is only 11 and 25 hundredths hours, and the phone will not last the entire 12-hour trip. It's going to die about 3/4 of an hour before they get there. Now let's try another problem very similar to that. Kita's phone had a fully charged battery. With normal usage, her phone will last 18 hours. How much time is left on Kita's phone battery with 12% charge remaining? So we want to know how many hours remain if she's only got 12% battery, if when she has 100% battery, it's 18 hours of use. So we're going to set this up into that ratio. Okay, make your first ratio the percents. So we have what percent compared to 100? That's your 12%. So that goes on top of the 100. And the X is the hours of use. Remember, this is the part. This is the part of the phone battery that is charged, and X represents the part of the hours that remain, compared to the whole, which is what happens when the phone battery is completely charged, and that whole is 100% or 18 hours. So I'm going to actually take this over here to the side because I know that sometimes these boxes get a little confusing, and we're going to rewrite this and solve this out to the side. So here's what your ratios look like. Now, to solve this, again, we have that division equation, x divided by 18. So in order to solve it, we're going to multiply both sides by 18, okay? And when you do that, hang on, let me go back to my black pen here. We get x on the right, and then on the left, we have to do 18 times 12, and then 1 times 100, and simplify it. So what is 18 times 12? 18 times 12 is 216, and then 1 times 100 makes 100 on the bottom. And then in order to simplify that, we're going to do 216 divided by 100, and we get x is equal to 2.16 hours of battery life remaining. So now looking over at the boxes, I just want to show you what would fill in each of those boxes so that you know how to solve this. So we would first do our two ratios, and then we multiplied both sides by that 18. And then we came back and we said x is 2.16. My pen's not working. There we go. So Kita's phone battery has about 2 hours, or 2.16 hours remaining. Now let's take a look at the convince me. Why is 51% of a number more than half of the number? Well, think about that percentage. How does 51% compare to 100? Is it more than half of 100? And the answer is yes. So because 51% is over half of 100%, what would half of 100% be? Well, that would have been 50%. Okay. Then 51% of a number has to be more than half of that number. All right, now let's go on and take a look at example 2. Example 2. In this example, we're going to use percents greater than 100%. A full set of adult teeth includes 160% as many teeth as a full set of baby teeth. How many teeth are there in a full set of adult teeth? So in other words, the adult teeth are what we're looking for. And we know that we lose our baby teeth. Eventually we lose them all. And we have adult teeth that come in their place. But we also have some extra adult teeth that we did not have as a baby. So that's why there's more adult teeth than there are baby teeth. We're still going to set this up in a proportion. So we're going to set this up using our ratios, okay, where the adult teeth is still the part and the whole is always the 100%. Always 100% equals the whole, okay? So as I set this up, I'm putting the part in the numerator, that's the 160, and the t, okay, so this is the part, and that's the number of teeth that represents the part, out of or compared to the whole, which is the 100%, which is 20 teeth. So right now the whole amount that we're talking about is the whole amount of baby teeth, which is 20. In order to solve this, we're going to do the same thing that we did before. So we've got a division problem, t divided by 20. So we're going to multiply both sides by 20. Now remember, 160 over 100 times 20 means times 20 over 1. So you're going to do 160 times 20, and then you're going to do 100 times 1. And here's your ratio, 3,200 over 100. Now you just have to finish by dividing, and you should get 32. So 32 adult teeth and 20 baby teeth. So a set of adult teeth includes 32 teeth. And remember, we expect this number of teeth to be larger than the number of baby teeth because the percent was larger than 100. So the answer is larger than the original value because the percent is larger than 100%. The answer is larger than the original number, which was this 20 baby teeth, because the percent is larger than 100. Remember, we took 160% of that 100. Now we're going to look at example 3 and using percents that are less than 1%. So these are going to be super small numbers. What is the approximate distance in miles from Earth to the moon? So step 1 is to draw a bar diagram and write the equivalent ratios. So what we know is that we know the percent of the distance between the sun and the earth, and the sun, or in the earth and the moon, is 27/100%. So compared to the distance between earth and the sun, we are at 27/100%. So here's our percent ratio. We compared our percents. Okay, the part is on the top, so that's the part that we're looking for. And the whole is always that 100%, which is on the bottom. The miles, okay, right here, compares the miles between Earth and the moon. Okay, that's this one that we're looking for here, and Earth and the sun. So we're still going to solve this proportion just like we did before. We have x divided by 93 million equals 27/100 over 100. So that's what our proportion says. In other words, in order to solve for x, I need to multiply both parts of this ratio by that 93 million. So this is the math right here that I just put a box around. That's what I'm going to be solving. Now remember that 93 million is 93 million over 1. So when you multiply this, you're doing the 27/100 times 93 million, and then you're going to divide that by 100 times 1. And when you do that, you get 251,100 miles. So that's about how far the moon is from Earth. So the triads at the bottom look quite different because these are not in word problem form. So we're going to set these up first in our ratios, our equivalent ratios, and then we're going to solve for that missing piece. So in each of these, the one whole is the 100%, and the one whole is how much we're finding out of the 720. or in part B out of 200, or in part C out of 60. So I'm going to first set these up as our equivalent ratios. And then I want you to try to solve them. So notice that my percent ratio I'm putting first, and then my ratio to find the other piece is going to come second. So we've got each of these compares the percent of the part to the whole percent, which is 100, and then we're trying to find how much out of that value. So in part A, 8 hundredths is the part, 100% is the whole. X is the part that we're looking for out of, that's the out of here, the 720, which represents the whole. So we're going to solve for X in that case. In part B, we're looking for 162 5/10% out of 100%, which is the whole. And that's equal to how much, that's your X value that we're trying to solve for, out of 200. Okay. And in part C, we're looking for 0.3% compared to 100 equals what number out of 60. Okay, so in each of these cases, we're going to solve for X using our strategies for solving equations. So try those to solve for X, and then come back and check your work and your answer. All right, go ahead and check your answer. Pause the video if you need to. Take a look at the work and what I did to each side of that equation. Remember that when you multiply a fraction by a whole number, you multiply the numerator and the whole number together, and then the denominator gets multiplied by 1, and then you have to divide again to simplify. All right, so let's do a quick review using the key concept. A percent is one way to represent the relationship between two quantities, generally that of a part to whole, like a fraction. Okay, so fractions always show us a part to whole relationship. So I've taken the bar diagram here, and I've indicated that the part is the blue stuff. So that's generally the pieces that we are given, and we're looking for one of those pieces. Compared to the whole, well, the whole is always that 100% and the amount that represents that 100%. So we're going to create our equal ratios using our percent as one ratio. So compare our percents, and then compare our amounts that represent each of those percents in the second ratio. For the practice problems, I'd like for you to try to work on questions 4, 5, 7 through 12, number 16, and numbers 20 and 21. We will go over these together in class, so if you have questions, feel free to skip that problem and come back to it later. If you have questions about how to do the work, come see me and I'd be happy to show you.